All right, so now we're on to our second video for the AP questions on differential equation, and this is the year 2002. Again, it's probably tough for you to read, so hopefully you have a hard copy in front of you. 2002, number 5 says, consider the differential equation, so they're giving me the derivative. Already I'm thinking I might have to separate and integrate. Okay, that's already going through my mind, but let's see what they're asking. They're saying let y equals f of x be the particular solution to the given differential equation from 1 to 5, such that the line y equals -2 is tangent to the graph of f. Okay, that's a lot of information right there. And anytime I get stuff that I feel that's not a common question, I didn't get an initial condition. I did get a condition, it's just not in the form of a point. I want to visualize it. So they're telling me that y equals -2 is tangent to the graph of f. So in my head, I don't know what f looks like. So I'm giving myself a sketch. But I know there's some curve. And I have this line, y equals -2. And they're telling me that the curve of f is tangent to it. So it's touching at once. So it could be going like this. It could be going like this. I'm not sure. The only thing I do know is that there's a point on f where the y value, I don't know what x is. I have no idea where x is. X could be in the negative range. I have no clue yet. But I do know that there's a y value with a -2 because it's tangent. I also know if it's tangent at this point, at that very point, if it's tangent, the slope dy dx has to be 0 when y is -2. Again, I don't know what x is, but does that make sense? If something's tangent, all right, we know it's a horizontal line, well then it's the slope at that y value is going to be -2. So let's continue reading. It says find the x value of the point of tangency and determine whether f has a local max or min. All right, so now they're asking me to find the point. And I go, okay, well, what information did they give me? They gave me that dy dx, which is fancy for the slope, is represented by this, okay? And I just figured out, I kind of talked it out loud already with you, is that if I have a horizontal line that's tangent, that means it's only touching one. So at that y value, the slope has to be 0. So dy dx is 0 when y is -2. Does that make sense? Hopefully it does. And then I fill in 3 minus x that's there, and now I have enough information to solve for x. I have a fraction equal to a number. I can just cross multiply. I get that 3 minus x is equal to 0 times -2 is just 0. I add the x over, and I realize that x is equal to 3 when that situation occurs. So the point 3 -2 is where that point of tangency is happening with y equals -2, and 3 -2 is also a point on f. That's also something else that I found out. So here, now they're asking me, okay, if I have a local max or min at this point, okay? Because think about it, I either got to be curving up or curving down if it's going to be tangent, not going through it. So now I'm thinking, anytime I want a max or a min, that usually goes off the first derivative. So I'm going, well, I was given the first derivative. If I look at this, 3 minus x over y equals 0, you take your first derivative, you set it equal to 0, and I get the critical value of x equals 3. We already did that. I put that on my number line, and my issue is that I want to plug into the first derivative. Well, these are just x values. I don't have y values, so now I'm stumped. I'm going, well, that can't work. I cannot use the first derivative in the form that I've always have because I don't have y values to plug in when x is 4 or when x is 1. So now I got to think a little bit outside the box, and I'm thinking about max and mins. And I'm looking at this. If it's a minimum, it's part of a concave up. Do you see that? And if it's a maximum, it would be part of a concave down. Well, we know that concavity comes off of the second derivative. Concavity is my second derivative. So now I'm saying, well, I do know this point is present. And if I take a second derivative and plug in this point, I'm just going to see, is that value positive? Because if it's positive, it's telling me it's concave up. So that would infer that this is going to be a minimum. If I take the second derivative and plug in the point of 3, -2, and I get that it's a negative value, well, then it would be concave down, and that point would then be a max. So that's where when I get stuck, you want to keep on thinking about all the other tools that you have, and we would use the second derivative here. So let's go and take the second derivative. dy dx is equal to 3 minus x over y. I have to use the quotient rule. All right, so the second derivative, here we go, is equal to, the derivative of the first is -1 times the second, minus the derivative of the second. Well, the derivative of the second is dy dx times the first all over the second squared. And I go, all right, well, I know the point x and y is 3 and -2. And then I'm thinking, oh wait, I figured out dy dx at that point. We figured out that dy dx at when x was -2 and -3 is 0. I mean, not negative. When x was 3 and -2, dy dx at that point is 0. So I just plug in -1, -2 minus 0 times 3 minus 3, which also gives me 0, all over -2 squared. And when I do this math, I just get a +2 minus 0 over 4 is equal to 1/2. And I'm not really concerned about the value as far as I'm concerned about the sign. The sign's positive. The second derivative is positive at that point. Therefore, if it's positive, it's concave up. And that point is now a minimum. I can say with confidence that that's a minimum. All right, so that was part A, and that's what would be your justification, that because the second derivative is positive, the f of 3 is concave up, and therefore it's a minimum. All right, so let's talk about part B. Part B now kind of switches gears. Part B no longer, so how do I know it switched gears? Here it said y in part A, let y equals f of x be a particular solution. Now part B says let y equal g of x. That's a different function with a different particular solution, but they're still using the same given differential equation. And now they're giving you a different domain of -2 to 8. All right, so now it continues to say that I have an initial condition. So right then and there I go, oh, that's probably going to be used to find my particular solution. All right, it's 6, -4. All right, well, I'm going to use that point as my initial condition. I'll use that later. And at this point, there's using the same differential equation, dy dx equals 3 minus x over y. And I want to get to g of x. I need to integrate, because right now I'm at a derivative. So I have to separate variables again. So I times this by dx. I times this by dx. That goes away. I get dy is equal to 3 minus x dx over y. And I need to get rid of that y because over here tells me only y's can be over there. So I times this by y. I almost did that again. Times that by y. And now I have y dy is equal to 3 minus x dx. I'm able to integrate. So now when I go to integrate this, this becomes y squared over 2 plus c is equal to 3x minus x squared over 2 plus c. I just move over the c. I want 1c. Y squared over 2 is equal to 3x minus x squared over 2 plus c. Remember, that doesn't cancel out. It just gives me a different c. At this point, I have 1c. Even though y is not isolated, I can go ahead and plug in my initial condition. When x is 6, so everywhere I see x, I'm going to put a 6. Y is -4. So now I get that 16 divided by 2, which is 8. And then I get here 18 minus 6 squared is 36 divided by 2 is 18 plus C. Well, that tells me C is 8. So I go back to what I call the general right up here. Right here, that's considered, well, we'll actually write it here. That's my general solution. Once I find my C value, I go back there and I go y squared over 2 is equal to 3x minus x squared over 2 plus 8. Now I want to solve for y so that I can rename it g of x. I'm going to times everything by 2. I definitely don't want to deal with that fraction. So I get y squared is equal to 2 times 3 gives me the 6x minus 2 times 1/2, the 2's go away, I get x squared, and then 2 times 8 is 16. And now I square root. And when I square root, again, I know that there's a possibility of a plus or a minus square root of 6x minus x squared plus 16, but I look at the condition that they gave me, and they want my output to be a -4. They want your y to be negative. So you know all even roots give out a positive, so therefore I want the negative. I'm going to want that negative out there, and my final answer is y equals negative square root of 6x minus x squared plus 16. And that's it. You might even want to take, you could leave it as y equals, it's also considered g of x. And that's it. So what I did was I assigned you the 3 following problems to do. I don't want you to do the last one. That's 2011. We'll do that together. And I look forward to maybe seeing some of you on Friday. I'm going to do another Google Meet that day to just kind of go over any problems. And hopefully you're watching that AP board. I think I wrote when they taught about slope fields, if anybody's been watching the AP board classes. I didn't love the second day. I will make comments on whether I think it's a really good video. I think the very first day, their first lesson was great, basic but good. And the second one I thought was a little silly because it was trial and error. And hopefully by now you've read the guidelines and there is no multiple choice this time. It's just going to be free response, 45 minutes on this test. I'm confident that you guys are going to do well. So email me any questions and get the homework into me by Wednesday at 11 a.m. Thank you.